Hello, welcome to today's video for section 9.3. This is going to be the first of three in a series that we're going to be doing this week. Today we are going to just get a better understanding of the greenhouse effect, what exactly it is, and how that affects climate around the Earth. Okay, so let's get right into it. So the greenhouse effect, you might not realize, but it is a natural phenomenon. So it is a really good thing because it really helps to moderate the climate temperatures and things like that around the world. It is the responsibility of our atmosphere. So basically, it helps to hold heat in that comes from the sun, which helps to keep the earth warm. Without it, the earth would be much, much cooler. And the temperature variations would be a bit larger too, okay? So without the greenhouse effect, it's easy to imagine that life would not be able to exist, at least at the capacity that we're at right now. There would just be too much variation in temperature for species to be able to survive. Okay, so how does it work? Basically, I mean, we know that the sun sends UV radiation to the earth, okay, so UV being ultraviolet, and that ultraviolet light is able to travel through the atmosphere to Earth's surface, where it is going to either get absorbed or reflected. So a good bit of that UV radiation does get reflected back into space, but some of it gets absorbed. And some lower energy radiation, so no longer UV, but infrared, some of that will get emitted back out of the surface of the Earth into the atmosphere, and it would otherwise go out into space, but some gases in the atmosphere will actually absorb that infrared radiation that is coming back, okay? So the Earth's surface warms from some of the UV light that gets absorbed, but then the atmosphere is going to warm further by trapping essentially the infrared light as it gets emitted back into space. Okay, it doesn't absorb all the infrared, but a good bit of it, so that helps to keep some of the energy coming from the sun in Earth's atmosphere. Okay, so this is a little bit blurry, but that's okay. But we can see the sun here sending UV light to Earth. A good bit of it gets reflected back into space, but about half of that solar radiation does get absorbed by Earth's surface. And some of that will contribute to the heating of Earth's surface, but also some of the solar radiation is going to get emitted back out of the surface, as I said before, infrared. So infrared is a lower energy wavelength of electromagnetic radiation. So while the greenhouse gases did not absorb the UV in the first place, they do absorb the infrared, okay? So that's what happens here. So some of it gets absorbed, some of it will go back into space, some of it will get reflected back to Earth's surface. But the key here is that some of the energy that would otherwise just be going back out into space stays in the atmosphere and can contribute to further warming the Earth's surface. Okay, so some of the most common greenhouse gases, you've most definitely heard of carbon dioxide and methane as big greenhouse gases. Those are two that we've already mentioned in this class. But some that you might not realize are nitrous oxide, N2O, water vapor, H2O, and chlorofluorocarbons, which we just talked about, as well as their replacement, hydrofluorocarbons, the HFCs, which these guys contribute to much more greenhouse effect than these other gases do. Okay, but just by the sheer amount of carbon dioxide that we're putting out into the atmosphere, carbon dioxide is way more impactful. So basically all of these, their greenhouse global warming potential is based off of carbon dioxide being 1, methane is 25 times more powerful, nitrous oxide 300, and these fluorocarbons are way more. Okay, so going back to that data there, the carbon dioxide or CO2 has a global warming potential of 1, so GWP. That might be something that you will see again, so remember that abbreviation. So carbon dioxide is used as the reference point because everybody knows about carbon dioxide as being a greenhouse gas. So we use that as the baseline, and then everything else is based off of that. So clearly we can see that carbon dioxide is has a lower impact than the rest of these. But again, like I said, it does have a lot more impact as a result of just the amount that carbon dioxide is in the atmosphere. Okay. All right, so just in terms of strength from highest to lowest based off of this data here, based off of our diagrams over here, HFCs are hydrofluorocarbons, and then chlorofluorocarbons are the strongest greenhouse effect gases. And then ozone, which is actually a new one that we haven't mentioned quite yet, nitrous oxide, methane, and then carbon dioxide. Okay, so that is all for our 9.3 section, so stay tuned for 9.4.